you will not differentiate y. Then you add it plus, now we are differentiating y, differentiate f respect to our y, then you hold x constant. This is the product rule we knew earlier on. So you differentiate one and hold one constant. This is what we have here. This is the product rule. Okay. And then because we are dealing with integration, you guys have to multiply both sides by the integral sign. And that is why we are seeing that we take the integral sign of this, we put the integral sign here, and put the integral sign here, and put the integral sign here. Okay, so that when you integrate this one, because of the integral sign here, this dx is going to vanish. So you have dy. Okay, and then the rest, you just apply the differential sign, the integral sign into them. So look at this part. This part is the same as our du. It means that we are differentiating respect to our u. And this is also our dv. So here you are differentiating respect to v. And that is why we simplify this one into du and then dv. So the function becomes simple now. And if we integrate this function here, we are going to get our y. So our y is now equal to the integral of v, which is the first one, and then du, which is the second one. This one is the u2, which is the first one. And then this is the v. This is also the v that we have. Okay. So we want to simplify it and then to see what we are going to get. Now, when you have this one, the next one is to let our y, because we want to divide it into two parts. Let our y is equal to our uv. Let y is equal to uv. So that is the first scenario that we have here. You should let the rule of the product differentiation state that if our y is equal to uv, so if y is equal to uv, it means that in place of y here, we are going to substitute our uv there. So y is equal to uv, then we can make so we now have our uv to be equal to the integral of uv du, the integral of v du plus the integral of u dv. Yes. So we can make, when you have this one, we can make u dv the subject. You can make this one the subject. So if we send this one across, this one is going to be this one minus this. That is what we have in the fourth equation. We are just making the integral of u dv the subject, and that is what we have here. And this is the general formula to find for the integration by part. This is the general formula to find the integration by part. So the general formula to find the integration by part is this. So whenever we are given example or a question to use the integration by part, this is what we are going to follow. We have our u here, dv. We have u, we have v, we have the integral of v du. Okay, so let's look at example by how to apply the formula to do the integration by part. Using use the integration by part to solve this problem. Integration by part to solve this problem. So let's see how we are going to solve that problem. And again, I think I have to open I have to open the word so that we can do it there. Okay. So I hope we can see this the board.
Yes, sir, we can see.
Okay. So let's do the integration by part. And then we need to note that this is the formula we are supposed to use. This is the formula that we are supposed to use. And then we'll look at how to solve this problem. Okay. Now, what we need to do here is that we have U here and we have the V. If you look at the function, it's in the same format. So let's say let our U be equal to our 4x. The one that is attached to the function, the 4x. So that we can say we can differentiate our U. We can differentiate U with respect to x. With respect to x. So if we differentiate U with respect to x with this one, the 4x, you are going to get 4. So we have gotten our U. So take note that we have U here and we had what? V here. So we are supposed to find for the value of U in V and come and subtract it. So we know that our V, our U is given. So let's define our U. This is our U. Our U is equal to 4x. Now, what would be our V? Let's also assume that our V is equal to, so V, so let me write it here. Our V is equal to V is equal to bracket x plus 4. And this one is raised to power 9. 9. Yeah, raised to power 9. That is our V now. And you also have to understand that here we are having the V to be an integral form. Okay, so it means that we have to find the integral of V. We have to find the integral of V. So this is it is in the integral form. So we can say this is our V. Instead of V, it is our dv. The V is equal to this. Okay. from the bracket here, dv is equal to this. So when we have our dv, then we can integrate. When we integrate the dv, we'll get our v. Okay, so let's integrate our dv to get our v. So to get our v, we need to do the integral of the dv. So the dv is equal to the integral of x plus 4 raised to the power 9. So this one will give us our v. So when we integrate our dv, this is 4x plus 4x plus x plus 4 raised to the power 9. Please take note that this is a composite function. So when you are integrating, you don't have to say that, oh, let me multiply this by x. It's the whole function you are integrating, not only x. You have to remember that it's the whole function you are integrating, not only x. So what we are going to do is that, integrating, when you're integrating, you add 1 to the exponent and divide all by the exponent. So when you are going to integrate this one, you are going to get the same function. Take note that integral, because this one is a composite function, we are integrating the whole function, not only x. So we are going to have 4. Then you add 1 here. Then that will give us 10. Then you divide all by the 9 plus 1. 9 plus 1. And that means that you are also define this one by 10. And this one is going to simplify to give you, I can separate the 10 out. That is 1 over 10. 1 over 10, our bracket x plus 4, all raised to the power 10. Okay, so this is what we are going to get for the integral. So we integrate the dv to get the value of v. Okay, so we have the value of v, we have our u. Remember that the function is the value of u multiplied by v, subtracting the integral of v du. So we are now done with the values. So the next thing is to also now do the substitution. Let's do the substitution now. Okay, and then how do we do the substitution? We know our v, we know our u. The first part here, we know our u. This is our u, and we said let u is equal to 4x. So we are going to get our 4x. We are going to get our 4x. So this function is going to give us 4x. So let's look at this first. Okay, so this one is the same as the function. So we are going to get the integral of 4x. Then x plus 4 raised to the power 10. Sorry, 9. Okay, so we are now integrating this. Remember that we are taking the integral of 4 and dv. What is 4? What is, u? What is u? U is 4x. We are missing it here. U is 4x. And what is dv? Dv is x. Dv is x plus 4 raised to the power 9. So it's the same as this one. Okay, so we have to take the integral of this one in order to get our uv. In order to get our uv. In order to get our uv. So let's do the integral of this. Now, we have already differentiated we have already done the integral of 4x, and then so to the value of this, v here or u here is now our 4x. So let's write our 4x. And then what is our v? We integrated the v and we had this value. So we are going to multiply this one by our integral of the v, our v here, which is this one. And that will going to give us 1/10. Let me write it well. It's going to give us 1/10. 1/10. Then bracket x plus 4 raised to the power 10. Okay. And this one, we are going to subtract this one from, we are going to do this, the subtraction by integrating the whole of the function v du. Okay. So let's do the subtraction first. So if you are going to integrate this one, let's integrate this one before we do the subtraction first. So if you integrate this one, no, not integrate. If we simplify this, let's simplify this one first. So multiply this one by this, you are going to get, let's do here this simple one. Let's simplify this. This is multiplying this. So if you do that, you are going to get 4x over 10. 4x over 10 bracket x plus 4 raised to the power 10. This is what you are going to get. And now 2 will go here, 2, and then 2 will go here, 5. 5. So we are going to get our function to be now 2 over 5 bracket x 2 over 5x. There's x attached to it, x 2 over 5x. Then we open a bracket, x plus 4. X plus 4 raised to the power 10. So this is what we have for the uv from the formula. This is what we have for the uv. Where's the formula? This uv here. And you know that if you look at the other side, it's the same thing, uv. So if we have the value of uv, to get the other part, we just have to take the integral of the uv to get the other part. Okay, so what we are going to do here is that, you know that the uv is subtracting the integral of v du. So we have to just take minus the integral of this one. The integral of this one, the same thing, they are the same thing. The integral of 2 over 5 bracket, oh sorry, x here before the bracket, x plus 4, then raised to the power 10. Raised to the power 10. And this is equal to, this is the x. Is the x. So this is what we have. Now let's take off the integral sign here. It means that we have to integrate this function in respect to x. We have to integrate this function here. So how do we integrate this function? We are going to get 2 over 5x bracket x plus 4 raised to the power 10, and this one is minus, let's integrate this one. Take note that I said earlier that when we are integrating this form of function, you are going to differentiate the function as a whole, not individual variables, because it's a composite function. It's a composite function, so you cannot integrate. You cannot integrate only x alone or only 4 alone. they are together. So you have to integrate the function as a whole. So what we are going to do is that you are going to add 1 to the exponent, and then you divide the whole function by, you multiply it by what? So here it's going to be plus 1 here. Then you multiply or divide the whole here by 10 plus 1, that is 11. So here you're going to, let me just do it 11. So here, okay, so that's the next one. So here is 10 plus 1. 10 plus 1. And here is 10 plus 1. 10 plus 1. So that you are going to get the final answer is going to be give you 2 over. So here you are multiplying 11 by the whole of this function. So it's going to affect the 5 here. 11 by 5 is going to give you 55. So you are going to get 55 here. And then you now bring the bracket, that is, remember x is there, that is x plus 4 all over 11. And you know that when you integrate any variable, we are going to add constant plus our c. Plus our c. So this is the integration by part. We divided the function into 2 equal parts. That is u v, and then the integral of u dv. So we divided the function into 2 equal parts so that it can make it easy for us to integrate. Let's quickly look at another example. There's another example there. I'm just going to copy it and bring it there so that we look at it. Let's look at another example on how to do the integration by part. Okay, so another example. So this is another example. We have x and then bracket x keep plus 1. So with this one, we are going to say that let our u is equal to x, so that we can differentiate our du with respect to our x. Then we get 1. Then our dv is equal to our dv is equal to the one in the bracket, that is s raised to the power 3 plus 1. Okay, but we want v, not dv, because the formula here is u v. So we have our u to be equal to x, but we don't know our v. To get our v, we have to integrate this one to get our v. So our v will be equal to our the integral of the integral of x raised to the power 3 plus 1. So if you integrate this one, what are we going to get? We are going to get this one plus 1 divided by this. You are going to get 1 over 4. Then x, you add 1 to the x, you'll be getting 4 here. Then this one is going to turn into x. Going to turn into x. So this is how we integrate. This is how we integrate our dv to get our v. Now that we integrate the v to get the dv to get our v, we can now go to the formula and substitute. What is our v? So our function here, that is x bracket x3 plus 1 is equal to our v. What is sorry, u first. We said let u is equal to x, so x. And what is our v? Our v is now this one. Our v is now 4x, sorry, 1 over 4 x raised to the power 4 plus x. Okay, then subtract. We are going to subtract from v du, but it's integral form, so it's the same as this one. U dv is the same as this. This one and this one are the same. Get that this one is du. So for us to get the du, this one and this one are the same, we can just integrate this one to get our this. And that is why we are going to subtract this one by the integral of the same function as this one. The same function as this. So we are going to get 1 over 4, 1 over 4, and then we have our 4 x raised to the power 4 plus our x. Now let's simplify this one. You know that this is not any integral. We are just going to simplify it. So if we simplify this one, we are going to get this one will multiply by this. We are going to get 1 over 4. But this one is also multiplying by this. This one is also multiplying by this. X to the power x 4 is going to give us x raised to the power 5. Remember the product law of multiplication. If you are multiplying variable that they have the same base, you have to add the exponent. Any number standing alone is over 1. So when we are multiplying this one and this, the base are the same. So you get add the exponent. That's why we have the 5 here. And then the same thing plus x multiplied by x. You are multiplying them. It becomes x squared. Okay. And this one, let's integrate this one. Let's integrate this. And remember, I said that when you are integrating this, it is telling you that you are integrating the whole function here, the whole function. So here is okay. Okay, so let's move on to the integral of this. So this one we are able to open the bracket. Cool. So let me rewrite this one well. It's 1/4. This one is bracket 1/4 1/4x raised to the power 4 plus x plus x. Yes, so this we have. This is what we have. Okay, sorry, this is what we have. So let's integrate this one. Remember that this one is not a function, but it gets a normal. It's not a composite function. It gets a function standing alone. Okay, so let's integrate x respect to x. We are not. This is not a function that a composite function that you are saying. A composite function is in the form of this, where we have a number into bracket. So this is standing as a function of on itself. So we have to differentiate respect to the variable itself. So let's integrate. Sure, we have to integrate with respect to the variable. So if we integrate with respect to the x here, we are going to add 1 here. Then you multiply by 5. And then here too, it becomes x2. So here we are going to get, if you multiply 5 by 4, you are going to get 1/20. You're going to get 1/20 x raised to the power 5. X raised to the power 5. And then we integrate the x. The x is standing alone. You integrate it. You are going to get, this is already standing with 1. So plus 1, it becomes 2. So plus x squared all over 2, because we are going to multiply the 2 as well, all over 2. Okay, so you can rewrite this one as 1/2 x squared. So this is the integral of the second part. This is the integral of the second part. Okay. Now, let's see how we can simplify this. And you know that when you integrate a function, you are going to add a certain variable that is constant. Okay. So let's see how we can simplify things here. Let's see how we can simplify things here. Okay. So let's open, I want to open the bracket so that we can see things clearly. So we have 1/4 x raised to the power 5. X raised to the power 5. Now, I have 5 raised to the x raised to the power 5 here. I want to group like them. So this one, I will bring minus 1/20. 1/20 x raised to the power 5 here. Okay. Before I bring my, so this one and this one has taken care. Before I bring my x squared plus 1/2 x squared. 1/2 x squared. So I'm getting grouping items so that we can get the picture well. Now, after you group item, what is next? We can find the LCM here. Find the LCM here. It's going to give you 20. LCM here is going to give you 20. So 20, 4 will go to 20. 4 will go to 20, that is 5. So you have 5 multiplied by this. So you have 5 raised to the power. So, okay, so here again, let me do it this way. The common factor is 20. All right, so I multiply here by 20, multiply by here by 20. Okay, so that is what, that will make it easy for us. Here by 20, here 2 by 20, so that this 20 can cancel this 20, and this 4 here will go here 1, 4 here will go give us 5. So we have 1 over 5 x, 1 over 5 x raised to power 5. Okay, then we have this one too. This one will
Doc,
cancel
please.
here. Yeah.
Doc, please. Is it not the 5 multiplying the 1 is 1s to the power 5? Your division that you did.
Yeah, 20 times 1 over 4. The cancellation.
So 4
20.
4 into itself 1 and into 20 will be 5. So I think it will be 5s to the power 5.
Okay, sure. So 5. Yeah, sure. So you have 5x to the power 5. Then here will give us minus x to the power 5. Then plus this one too, we can do the same thing here. We can do the same thing here. Okay. So we can do the same thing here, so that we are going to get plus let's say 2x squared plus our, there's 2x again, because okay, x squared, because we multiply here by 2, here by 2. Okay, so that they can also go off, and that is what we have here.
So the two equations is two different entities. So we take different LCMs for that.
Yes, that. Yes, maybe we can also take if you want, we can take the as a common 20 can go through all of them, right? Yes, we can do that.
Yeah.
We can also do that. I think if we do that, we're also going to get the same thing.
Oh, okay.
Yeah. Oh, sorry. Where's the function? Sorry. I think I've made some mistake somewhere, because there's a bracket somewhere. Oh, I'm coming. Let me go back to this. Go back to this, so that this is the original function for to the power. This 4, and they are all in bracket. So let's put this and this, and then let's put this and this. Okay. So if we want to open the bracket, this one, the minus is going to affect all of this. The minus is going to affect all of that, right? So if the minus is going to affect all of that, it means that if I have, let me deal with this one first. If I have 4x 1 over 4 and then 1 over 24. They are all the same. Okay, so it means that I'm going to do this one minus this. And then if I also open a bracket, this minus is going to affect this one here. So it's going to be x cube minus half x cube. So it just means the x here is over 1. It gets 1. Let's say it's 1. And here 2 is half. Forget about the x squared because they are common. They are common. So if we subtract 1 from half, we are going to get half. You are going to get half. Do we get this one?
No, sir.
I'm saying that the x squared here, so we have x squared here. So let's open the bracket first. So we are going to have 1 over 4 x raised to power 5. We are opening the bracket plus x squared. This is minus, so minus 1 over 20.
Yeah.
1 over 20 x
to the power 5.
This is minus, it's affecting the bracket. So here become minus 2.
Minus 1 out of 2.
1 out of 2.
The power x to the power 2.
X to the power 2 plus, you can say minus our C2. But C is constant, so it doesn't matter. So we can say C. Now, we can clearly see that this x here and here are having the same exponent. The same. They are all x squared. So this is standing alone means it's 1. And this is half. So it means that it's going to be 1 minus half. 1 minus half is going to give us half, right? That is what I'm saying. 1 minus half is going to give us half because the one here is, they are all common. This and this are all common. So we are going to get 1 over 4 x 5. Now you can bring the this one minus 1 over 20 minus 1 over 20 and then plus our half, because if we subtract 1 from half from 1, we are going to get half. So we are going to get our 1 over 2 x squared here. Okay, this is constant. We can forget the constant or we can always add it. Okay, so this is what we are supposed to get. This is what we are supposed to get. Now, you subtract, you see this is half raised to the power x squared. They are not common. So you cannot even tag this one. So you leave this one and tackle, this is 5 raised to the power 5. 1 over 2 raised to the power 5. 1 over 20 x raised to the power 5. And then 1 over 4 x raised to the power 5. They are all the same. Raised to the power 5, raised to the power 5. They are all the same. So you can work with this one differently from this. This is x raised to the power 2. So it's not different, it's not the same. So you cannot use the same thing to work with them.
Okay.
So you have 1 over 4. You can work with this one separately. 1 over 4. Okay. Just a minute.
So are you going to find the LCM for that then, as we did
Yes,
previously?
So I think we are going to find the LCM. Yeah.
Yeah.
I'm coming. Just a minute. One. Okay, so that's let's move on. Sorry. So let's do simple here instead of yes, you can find the LCM here. Yes, you can find the LCM here. But let me also tell you the simple way to do it. Now, let me tell you the simple way to do it. This is 1/4, and this is 1/20. Are we following?
Yes, doctor.
1/4, 1/20. Just take your calculator and subtract. Do 1/4 minus 1/20, and let's see. Because the x here and here are the same. You can just subtract them directly.
Yeah.
1/4 minus 1/20.
Okay, I'm going to get 1/5.
Yes. So instead of using the LCM, you can just do this, or this one will give us 1/5. 1/5 x raised to the power 5. Now plus our 1/2, 1/2 x squared. Then we can now out this constant here is always plus. So when we have the bracket there, it doesn't affect it. So please don't ignore this minus here. So plus our 5. And this will be our final solution to the integral by part. Now, if we want to go back to our normal equation, okay, we can differentiate this one and see whether we can go back to our normal different the function that we have up there. So let's differentiate this one. You know that if you integrate a function, you get a differentiation. If you differentiate a function, you get integration. So when you have a differentiation, you can integrate it to get the other one. So if you have this one, let's integrate this one and see what we are going to get. So if you are going to integrate this one, differentiate this one with respect to x. First, we are going to multiply 5 by this. So if we multiply, it's going to be give you 5/5. So the 5 will cancel out. So that we have x to the power 4. Right?
Yes, doctor.
Yes. So plus if we integrate this one, this 2 will also come and multiply this one. So it becomes 2/2. So the 2 will cancel out, right?
X.
So we have x. Now this is a constant. A constant can be any number, 25. When you differentiate a constant, you are getting 0. So this is what we have. Now we can see that here, x is here, x is here. We can factorize x out. So we are going to have our x into bracket. This one will give you x raised to the power what?
X raised to the power 3.
Yes, 3. Plus what?
Plus 1.
Yes, 1. That's good. Now, let's compare this one. So we have x to bracket, x key plus 1. Let's compare it to the main function given to s and see. Look at the function given to s here.
Oh, okay.
Look at this. Look at this very well. They are the same.
Yeah.
Can you see that? Look at the function here. They are the same. So anytime you do the integral, you can always convert it to get the normal function. Okay.
Okay.
Yes. So that is integration by part. So I've demonstrated 2 examples. Now let's go to integration by substitute. I don't know. Yes, integration by substitute. So let me go to the slides again. I'll come back to this. I'll come back to the board so that if there's example for it to solve. So let me clean this board here. Okay, so let me move back to the word, then we'll do 1, 2 before we come back. Okay, so another method that we can use is by integration by part. Oh, sorry, integration by substitute. But this is just talking about the importance of using the integration by part. You can read that yourself. Now, the integration by substitute. Now, we have another rule that we have to follow to do the integration by substitute. In fact, we're saying that the integration by substitute is just a reverse of the chain rule for differentiation. We just saw that when you differentiate the integral, you're going to get back our original function. It's the same thing here. The integration of the product or the quotient rule, sometimes when you are differentiating or integrating a product or a function that is multiplying by a function, you use the product rule. And the same time, if you are doing the integration too, you have to be very careful when you are dealing with those parts. So sometimes it becomes very complicated for us to use a direct differential or integration to do that. That is the reason why we always, if we are given integral function that is so complex that you cannot integrate it directly, then we can use a simple rules of integration, either by substitute or by part. So by substitute, it means that we can express, if we can express an integral as a constant multiple to the other function, let's say u and its derivative. So we can divide it into the function and its derivatives. Then when we divide it into two parts, the function itself and its derivatives, then we can substitute them back to the original function to get our integration. So this is not going to be this is going to be easy on how we are going to do. So take note of this function there. We are going to use that example to work out. Now, what is the formula for integration by substitute? So we are saying that we are going to express the integral, that of the function, as a function of u and its derivatives. So if you have a function that is expressed in the form of x, this is the function that you have. It means that you can say let x equal to u, so that you will differentiate the u and multiply by itself. So it become u, and then you differentiate u again, u with respect to x. So we are multiplying the function itself by its derivatives. But remember that you have to first say that let u is equal to a certain number, so that you can differentiate that number and multiply it by itself. That is exactly that we are doing here. So if we say let x be a function, the integral of a function, then we can differentiate. So we say let x to be equal to u. So you have to multiply the u by the derivative of itself. Okay. Now, when you differentiate this one, du dx is the same as our du. I can shorten it as du. Okay, and that is why, and this du is multiplying by u. That is why we have our u du on the other side. This one, and this one is a function of x. And now we said x is u, so we get put f of u. And remember that when you integrate a function, you are supposed to add the constant there, so plus c. Simple as that. So when we are doing the integral by substitute, after everything, we are going to substitute everything back to the function, to this one, in order to get back our original function. So this is the formula that we are going to use to do the integration by substitute. So let's quickly look at it. Let's do that and see what we are going to get. So we're following this formula. It means that, yes, so this is where the calculation starts, but I think I can work it on the other board so that, so let me go back there. Let me stop this, and then I'll present the whiteboard, and then I'll copy this to the whiteboard. So I'll copy this to the whiteboard so that we can be able to follow it.
Because I cannot see what you said. The whiteboard.
You cannot see?
Yes, please.
Yes, Doc.
Okay, I'm coming. Can you see now?
No.
No.
Okay. Okay, so let me reshare it again. But what are you seeing?
Your profile.
That's blank.
Can you see now?
Yes, Doc.
Okay. Okay, so we are going to follow this format to do the integration by substitution, this one. In this. Okay. So this is the function. So first of all, let's say our u is equal to the one in the bracket, x plus 2. X plus 2. Now, in the function, we are saying let u is equal to this. And then look at here. Here we have u and du. But we know our u. Where's our du? Our du is when we differentiate this one with respect to our x. So our du over dx, which is the same as this one, is equal to when we differentiate this one with respect to our, sorry, this is the one in the bracket is cube, right? Sorry. So when we differentiate this one, we are going to get 3x squared. 3x squared. Now, what about our dx? So we have our u, which is equal to this. We have du dx, which is also equal to this. What about our dx? Where is our dx? Now, our dx can be found from here. We have to make dx the subject from here. Remember, we have du over dx, and this is equal to 3x squared. So I want to make my dx the subject here. What should I do? I'll cross multiply, or I'll multiply both sides by oh yes. So let me say if I cross multiply it, it's going to give it the same thing. I'll cross multiply. This is any number standing is 1. So I'll have my du. I'm cross multiplying. This one will go here and this one will go here. So du is equal to my dx 3 my dx. Oh, let me just write it. This one, the x multiplied by 3x squared. So I'm going to get 3x squared dx. But I'm looking for the x alone, not 3x dx. So I will divide here by 3x squared. I'll divide here by 3x squared so that this one can cancel this. And my dx is going to give me du over my 3x squared. 3x squared. So I have my du, I have my x. So I have my u here, I have my du dx here, and I have my x dx here. So I will now substitute them back into the function and see what I'm going to get. Okay. Let's substitute them back and see. Now, what is our function here? This is our main function. This is our main function here. This is our main function. So I'm going to get my main function is, let's say, the integral of 12x squared and then bracket x raised to the power 3 plus 2. Then you close the bracket and then dx. What does this mean? This means that my 12 is not affected. So I'll write my 12 there because we didn't define the 12 to be anything. 12x squared. What is x cube plus 2? I said x cube plus 2 is the same as 2 my u. I said let u is equal to x cube plus 2. So here I'm going to substitute the u there. So I'm going to have my u. Now I'm going to substitute my dx. You see this dx here? The dx we are fine here. I'm going to substitute it there. So it's now going to give me du over my 3x cube. So this is what I have. So I've substituted what I needed to substitute into the formula. Now, if we have substituted this.
So Doc, please.
Yeah.
Please, is it going to be 12s squared times u times du over the s squared? 3s squared.
Yes.
Okay.
Yes. So this is times, I put dot there. This times, okay. Yes. So that's how it's going to be. Now, if we look at this one carefully, we have 3x cube. We also have 12x cube. We can say that 3x and 4x are common. So this one will go to itself 1. This one will go to here. How many times?
4.
4. Yes, 4. So that will be 4. So at the end, what we are getting here is 4u because this one is gone. So we are going to get 4u and then what? du here because this one is also cancelled. So we have du. Now we have this. Let me rewrite it nicely, then you see what we are trying to find out here. We are going to take the integral of this. So it's going to give us the integral of 4 u du. But if you are doing the integral, this is a constant. We can always separate the constant by saying 4. Take the 4 out. So we have u du. U du. Now let's compare this one to this. Seeing that it's something similar to the function here, right? Get that the 4 was there and we separated the 4. So it's something similar to the formula. Okay. Now that we have this here, what we need to do is that we are going to integrate this one. Let's integrate it. So that is why the integral sign is there. So let's integrate this. If we integrate this one, remember it's du. So the du vanishes, and then we integrate only this. What we are going to get is this is going to give us 1 over 2. Sorry, let me give the 4 is already there. So 4 bracket. We'll integrate this one. We are going to get 1 over 2. And then bring our u squared plus our constant c plus our constant. Now our 4 is now multiplying. So if you multiply 4 here, it's going to give us 4 over 2. That's going to give us 2. So finally, we are going to get 2 u squared plus our c. And this is the integral method by substitution. You need to know the formula and you follow the prompt, or you follow the procedure to get your functions. Now let's do something and see. What we are going to get. Now we know that our u are set u are defined earlier that u is equal to what? My x cube plus what? 2.
That's 2.
Was it plus 2?
Yes, doc.
Yes, plus 2. So it means that if I can substitute my u there. So I'll have 2 bracket x plus x cube plus my 2 and then I can add my constant c. Okay. Now let's integrate this. No, this is integrate. Let's differentiate this and see whether we're going to get back our normal function. Let's integrate. Let's differentiate this. First of all, let's see how we are going to get this formula done. Okay, so here, please take note that this is the u here is raised to the power squared, right? Don't forget that. So we'll put the square here. If not, you will not understand why we are getting this. Did you get the last thing as the statement I said?
No,
Because
sir.
it's u is u squared, and u is equal to this. So you are supposed to square this one because the u is squared.
Okay.
Yeah, from here. Are we okay?
Yes, doc.
Okay. So when you do that, then we can now differentiate this one and see what we are going to get. So we are using the quotient rule. The quotient rule states that you are going to differentiate the function itself first. Then you go inside and differentiate with respect to x. That is what the rule say. So first, let's differentiate the function itself. To differentiate the function itself, you are going to multiply 2 by 2. And you are going to get 4. And then x keep plus 2. Then if you minus 1 here, it will go away. So you don't have anything. So that is what we have. Then if we differentiate the constant, you are going to get 0. Now we are going to multiply this one by the differential of x itself. What we have done here is the differential of the whole function. So we now differentiate with respect to the x itself. If you differentiate with respect to x, you are going to get 3x squared. 3x squared. You are going to get 3x squared. Yes, so 3x squared there that you are going to have. Okay. Now let's move on and see what we are going to get. Now we can, this is multiplication, so we can multiply this one by this so that we can simplify. 12 by 4 is going to give us 12x 12x what squared, then to bracket x raised to power 3 plus 2 plus 2. Let's compare this to our formula and see. Compare this to our formula. The function, the original function given here. You see that they are the same.
Okay, the same thing.
Yes. So we have to, sometimes when you integrate, you have to do the differentiation to see if you can go back to its original function.
Doc, my question is, how did you get the 4 into bracket s cubed plus the 2?
Okay, this one.
Yes, Doc.
Okay, so let me quickly run it up and you see. So it is coming from this 2x, 2 bracket x raised to the power 3 plus 2. It is coming from here. Now, here we use what we call the chain rule. The chain, I don't know whether the chain rule. You can go and check it out. So what it does is that you differentiate the function itself first. This is squared. You differentiate the whole function itself. The whole function is the whole of this one.
Okay.
Okay, first. Then you go in, you multiply it by the differential of x itself, or the variable of interest. Because this is a composite function. It's a function within a function. So you have to differentiate them separately. So if you are differentiating the whole function itself, the whole function itself is raised to the power 2. So you are going to multiply this 2 by this 2, and you get 4. Because we are differentiating the whole function, the inside there will not be affected because it's multiplication. So you write the same thing. X keep plus 2. And remember, when we are differentiating the whole function, this is 2. Remember that you are going to subtract 1 from here. And that is why the 2 will vanish from here. Okay. Then you are going to multiply this one by the differential of x itself, whether it is x that is a function or y that is a function inside. Any variable there, you are going to differentiate with respect to that one first, the second. So you are going to differentiate the function again with respect to x itself. So when you differentiate with respect to x, you are going to get 3x squared. And that is how we had it.
Okay, Doc.
Yeah. Yeah, so that is how. There's another example there. When you go, you can try it yourself. And then let's move on to okay. So yes, so that is it. So these are the example that I'm saying. When you go, you can try to integrate it using the you can decide to use the integral by part or substitution to see if you can solve them. Please try and solve it. If you are finding difficulties, then you let me know. Okay, so this will be the end of the first unit. Then we are going to move on to the second unit and see what.
So, Doc, of all these pages, there is another unit there.
This is the first unit now.
So how many units, Doc?
It's unit 1 and 2.
We have quiz last week, say.
Yes, I'm aware.
Hey.
Thank you, Doc. Hey, Doc, that one too is 109 pages.
Yes. Don't be afraid. You'll be fine. 101 page is not anything. It's matrices. You know what? You have learned matrices. You have learned matrices before. Have you learned matrices before?
No, Doc.
Is it a SHS matrix or
The same, similar to matrices.
Okay.
the SS own? Is it a SS own?
Yeah, SS own, but we guess added some few things. Okay. Can you see the slides?
Other one.
Okay. So let's start. Maybe let's do 1 hour or something before I will leave you. I cannot leave you right now. But we need to. By next week, we should finish this one. Next week is your quiz, eh?
Yes, Doc.
What time?
I think
Is it weekend?
a weekend.
That
Yeah,
would be
during the
yours
weekend,
on
Saturday and
Sunday.
Sunday.
Saturday. And this that one will not get half class, eh?
Sunday evening.
We can have it after the tea.
Sunday afternoon.
Okay. So we need to finish. We need to finish this topic
The following
before.
week will be Adam.
Yes, we need to finish this topic before exams to, like we did last semester. Or if I get time, that is, I'm not promising you. If I get time, I might do the tutorials with you again.
Okay, Doc.
Okay.
That is if I get time. If I don't have time, you do it your own.
So try and get time.
You will surely get time, Doc.
Oh, try and get time.
All things being equal. That's what if I say if I get time. If something comes up, then you have to go and do your own tutorials. The one who has been the one guy, I've forgotten his name. I think that guy is good. He can always lead the class to do the tutorial to help you guys.
Eliasu.
Is it Iliaso?
Yeah.
I can't remember. Yeah, I can't remember. But is your results out?
No, still not.
No,
Still pending.
Hey, what are they waiting for? Is it all your results or only that one?
Only that one for us.
Only that one.
For we reading social science. Only that one.
But the rest has come.
Yeah, the rest has come.
Yes, sir.
Is it good? Is it looking good?
If you check
You
the
take-
IC,
I God's
if you
grace.
check the IC status, they will write that we are not having a score for the first quiz for the Economics 1, Mathematics for Economics 1.
You have
Yeah.
no response for quiz 1.
Yeah.
No score for quiz 1.
But you've done the on quiz 1 and 2 online, right?
Yeah, you've done it.
So what are they saying?
So it means
Well,
they have not recorded it, or I don't know if they didn't record them.
is it not in their hands? They should do that and let you know your fate.
It's left with only the command.
Don't worry, it will come.
You don't know how to stand.
Maybe it's because
Okay.
the results for the quiz 1 was very abysmal.
Even if it was abysmal, whatever the people have gotten, you have to do it and then let them know their fate. It is in their control, so they can do whatever they want. What are they waiting for?
You can add and subtract it.
Adding and subtraction to how many are you? Are you not 20 something? You can use 30 seconds to do that.
Yeah, so
Okay. So let's move on to the matrices. Let's look at the outline, what you are supposed to do. Definition, addition and subtraction of matrices, multiplication of matrices, determinant of matrices, inverse of matrices, and Cramer's rule. You see, these are all things that you are familiar with. The only thing that you may find difficult is maybe the last two, but it's not anything. It's the application. The inverse is not anything. The Cramer's rule is not also anything. So let's quickly run through the definitions and then we have time for the inverse and then the Cramer's rule. Even if we cannot move into the two, we should be able to cover up to the determinants of the matrices so that when we meet next time, we'll finish it up with the inverse and the Cramer's rule. Okay, so in many analysis, we assume that variables are related by a set of dependent functions or linear equations. But sometimes we want to solve those linear equations and become problem for us. Matrices of algebra has come to clear those doubts and help us solve so many linear equations together simultaneously. So with the matrices algebra, it has at least two main advantages. It reduces the complicated systems that we have in equations. Sometimes they give you like 5 equations that you should solve them simultaneously, too complex. Using the matrix algebra, we'll be able to find it easy to express them. It is also adaptable to systematic method of mathematical treatment, and it is well suited and can be applicable to all computable problems. Even in computers, we can use Excel, we can use R, we can use so many MATLAB to incorporate the concept or to adapt the matrices in order to aid in our analysis. Now, definition of matrices. What is a matrix? Matrix is a rectangular array of numbers. They get numbers arranged in rectangular form. It can be numbers, it can be parameters, it can be variables. And each of these variables are carefully ordered. They know where they belong to. In the rectangular array, the variables, the parameters, the numbers are well ordered and they are within the matrix. We don't just put the numbers anyhow. They are well positioned where they are supposed to belong to. Okay. Then the numbers, we are talking about parameters, we are talking about variables. These are called elements of the matrices. So the elements of the matrices are the number, the parameter that we are talking about. Now, the numbers in a horizontal lines are called rows. Numbers in a horizontal lines are called rows. And the numbers on the vertical lines are called columns. So if I have this and this, numbers that are placed on these horizontal lines are called rows. And numbers that are placed on these vertical lines are called columns. So it starts from here. The confusion starts from here. The rows and columns, how we always interchange them. Let's take it once and for all from here. On the horizontal, they are called rows. On the vertical, they are called columns. Now, these are the example of matrices that we can think about. We can see numbers on the horizontal. These are called rows. So these are called rows. And then we can see numbers on the vertical too. These are also called columns. Okay, so we have the rows and the columns. And we said that these individual entity within the matrices are called element. But this is number, this is parameters, and this is variables. So all these one are elements of the matrices. And matrices can take different form. We have 3 rows and 3 columns. So we call it 3 by 3 matrices. We have 2 rows, 2 columns. We have 2 by 2 matrices. We can have 10 rows, 10 columns. We call it 10 by 10 matrices. So this is an example of a matrices. We can see that all elements there are well positioned and ordered. They are not get ordered anyhow. They are well positioned and well ordered. Okay. So matrix A is an array of numbers. Matrix B is an array of parameters, and matrix C is an array of variables. Now, the number of rows will represent R's, and the number of columns will represent it by C, small c, defines the dimension of the matrices. When we talk about the dimension, we are talking about the number of rows and columns in the matrices or in the matrix. So we use the R and the C to represent the dimensions. If it is 4 by 4, like I said earlier on, if the row is 5, let's say 4, and the column is 4, the dimension is 4 by 4 matrices. So we use the small c and the small r, which is represent the row and the c, to represent to determine can help us to determine the dimension of the matrices. And it always read by saying R by C, rows by columns. Rows by column. So if the row is 4 and then column is also 4, I say 4 by 4, 4 by 4 matrices. Then the row always precedes the column. So the row always comes first before the columns. Now let's move on to some definition. We have the square matrix. When we talk about square matrix in matrices, the number of rows and columns must be the same. the number of rows and columns are the same. So you have the row. If row is equal to 4, column is equal to 4, we call it square matrices because the row and columns are the same. But if you have row to be equal to 5, column is equal to 6, this is not a square matrices. So take note. A column vector, if the matrix is composed of a single column such that its dimensions are r by 1, then it is called a column vector. A column vector. So if you have a single o r by 1, this is row, and then the column is 1, we call it a column vector. But if you have 1 by c, we call it a row vector. The column here, the row is 1 and the column is c, so we call it a row vector. A row vector. Now, what about a null matrix? It is a matrix of any dimension in which the elements within the matrices are 0. The elements within the matrices are 0. The word null will give you a clue that we have an empty matrix. A null matrix means an empty matrices. The elements within the matrices are all 0, and that is what we call a null matrices. What about a unit or identity matrix? It is any matrix or any square matrices in which every element is equal to 1 except the elements on the main diagonal. The main diagonal. So if you look at the example that we have given here, this is identity matrices. This is called the main diagonal, and this is called the off diagonal. Or we can simply call this one the principal diagonal, and this is the off diagonal. So any matrices that have the main diagonal being 1, 1, and then the off diagonal being 0, 0 is what we call identity matrix. Identity matrices. Let's look at this 3 by 3 matrices. You can see that the main diagonal is 1, 1, 1, 1, and the rest are 0, 0. So we'll call this an identity matrices. So identity matrices are also represented by a symbol capital I. Capital I. This is identity matrix. So take note of the identity matrices. We'll be making good use of the identity matrix. So take note of it. Now, equal matrices. Matrices are said to be equal if they are of the same dimension and the corresponding elements are also equal. So we have matrix A, you have matrix Q or P to be equal to 1, -1, 0, 3, and matrices Q is also the same thing, 1, -1, and 0, 0, 3. The number of dimensions, this is 2 by 2, because you have 2 rows, 2 columns, this is 2 by 2. So it's a square matrices. This is also 2 by 2. It is square matrices. Now, despite them being the same, can the element there, the number of elements is also the same. So they have the same elements in the same position. Okay, the elements are positioned the same in both matrices. So we call it an equal matrices. Okay, so that's equal matrices. Let's go to diagonal matrices. If it is it is a square matrix. When we say a square matrix, they have the same dimensions. A diagonal matrix is a square matrix that has 0 everywhere except on the main diagonal. That is, except on the main diagonal. That is, the diagonal running from the up to the left or the lower part have elements. Now, this is different from identity matrices. With the identity matrices, we are saying that on the main diagonal, we have 1, 1, 1, 1 throughout. But with the diagonal matrices, we are saying that all the other part is equal to 0 except the main diagonal. The except the main diagonal. So if you look at this place, the upper one we have 0, the lower down we have zeros, but the main diagonal is, the elements are non-zero. So we call it a diagonal matrices. Take note that this is not identity matrices, because for a matrix to be identical, then all the main diagonals should be 1, 1, 1. But here is 1, -3, 1. This is not identity matrices. This is diagonal matrices. If you look at here too, you can see that the main diagonal, the main here is giving you -1 and 7. So it is called a diagonal matrices. Now let's move on to a transpose of a matrix. The transpose of a matrix. Now, when we say a transpose of a matrix, it is a process that involves exchanging rows to columns and columns to rows. So if you have a matrices, we can always take the transpose of that matrices by exchanging the rows to columns and columns to rows. Let's look at this, what I'm talking about. Now, we are looking at the transpose of this matrix. The matrix in the bracket is matrix A. And matrix A has element 3, 2, and 0. These are called rows. Take note, these are called rows. And these are called columns. So in the rows, how many are they? 1, 2, 3. We have 3 rows. How many columns? 1, 2. Okay. So we have 2 by 3. 2 by 3. Now, if we come to this place, so we can count the rows here. So we can count the rows here. The rows is 1 and 2, right? Yes, 2 rows. 2 rows. Then the columns is 1, 2, 3. So we have 2 and by 3 columns or rows. Now, when we talk about the transpose, we are saying that the rows become columns and columns become rows. So we represent transpose by using this symbol. Using this symbol, or sometimes we see A raised to the power T. It means the transpose. It means the transpose. Now, if you have matrix A and you want to take the transpose of this, you have to change these rows to columns and these columns to rows. So when we are writing this one, let's write this one vertically. So this one becomes 3. So you write this one in terms of columns. The columns is you write this one in terms of the rows. The rows are the vertical aspect of it. So here become 3. Here you write 2 here, and here you write our 0 here. In that case, you convert this column to row. It was horizontal, now it is vertical. You are changing the rows to columns. Okay. Now let's move to the second one. The same thing, you are going to get -6. You are changing this one to rows. You have 0 and you have -1. Okay, in that case, you have also successfully changed your columns to what? Rows. In that case, how many rows do we have? If you convert rows to columns, we are not having how many rows? 1, 2, 3. So it becomes 3 by 2. 3 by 2. The initial one was 2 by 3. But if we change them, it becomes 3 by 2. This is how we do transpose. Transpose simply means changing the position of rows and columns. Okay. Changing the position of rows and columns. It's the same thing that you have to do here. We have, if you have a vector of A is how many rows do we have here? We have only one row. One row. And how many columns do we have? We have 1, 2, 3, 4, 5. 5 columns and one row. So we can interchange the rows to columns. So this one, instead of writing it horizontally, you write it vertically. And this is what we are going to get. You start 6. So the transpose of this one becomes 6 to -1 and 0.5. You are just writing this one vertically, and that means that you are taking the transpose of that function. Now, if you have 4 by 4, this is 4 rows, 4 columns, so it's called a square matrix. 4 rows, 4 columns. We can take the transpose of this. The transpose means that change the rows to columns and change the column to rows. So if you are going to do that, this one, you are going to write it vertically. So let's write this one vertically. So you are going to have 6, 0, 0, 0. Yes, the zeros are 3. Now, and you take this one and also write it vertically. And also write it vertically. So you have 0, you have -2, you have 0 and 0. Then you take this one and write it vertically. You have 0, 0, 3, and then 0. Then you take the last one and write it vertically. You are going to get 0, 0, 0, 5. 5. So it's you can clearly see that the transpose of A is the same as the original function. There are some functions that if you transpose them, you will get the same thing. And this function is what we call the, yes, I think we'll come to that function there. Then we'll look at how it is. Okay, so that's the transpose that we have simply done. The transpose. Any question on the transpose? Hello.
Yes,
Hi. Any question on transpose? All right, so no question. Let's move on. Let's go to the triangular matrix. A triangular matrix is a square matrix whose elements above or below the main diagonals are all 0. Whose elements above? So the first one is above. The elements above the main diagonal. This is the main diagonal. The elements above the main diagonal are all zeros. So we have zeros here. And the elements below the main diagonal is also 0. And this is what we call the triangular matrices. Triangular matrices. So it has divided the you have divided the matrices into 2. Why it is called triangular? So if you take only this out, so this one is in the form of triangle. Yes, it's a form of triangle. That is what we call triangular matrices. This is the form of triangular. This is a form of triangle. This is also a form of triangle. So you guys take this one and this. It's a form of triangle. The 0 part are all form of triangle. So if you have that nature of matrices, we call it a triangular matrices. A triangular matrices. Yes, this is a triangular matrices. This is also a triangular matrices. Okay. Okay, so let's move on. and look at a symmetric matrices. Before a symmetric matrices, the requirement is that your matrices must be a square matrices. That is, it must have the same dimensions. So a symmetric matrices, if a square matrices and its transpose are equal, that is, if we transpose a matrices and is equal to its original function or matrices, then we call it symmetric. It means they are all equal. The function itself and its transpose are all the same, so we call it symmetric matrices. Before this one, we are able to do, we are transposing one and we saw that they are all equal. Okay, so if we transpose a matrices and it's equal to its original matrices, then we call it symmetric matrices. And these are examples of symmetric matrices. You can try to transpose this one and see you are going to get the original ones. So let's look at this. If you want to transpose this, you are going to write this one as rows. These are columns. You write it as rows. So you write this one vertically. So you are going to get one. You are going to get one. So let's circle this one. You are going to get 1, 0, 0. The next one, write this one vertically. You are going to get 0, -3, and then 0. The next one, write this one vertically. You are going to get 0, 0, and then 10. Compare this one with the original matrix. They're all the same. So this is what we call the symmetric matrices. Symmetric matrix. So we have 1, -3, 10. 1, -3, 10, and the rest are 0. So it is called symmetric matrices. If you transpose original matrices and it's equal to its matrices, it's called symmetric matrices. Idempotent matrices. Idempotent matrices is a symmetric matrices that produces itself when it is multiplied by itself. So if you multiply a matrices by itself and it is equal to its original matrices, then it's called idempotent matrices. So if you have a matrices A, and you multiply A by A, then you are getting A, then it is called idempotent matrices. Idempotent matrices. So we'll come to look at some of them and some example under that. Now let's move on to addition and subtraction of matrices. Addition and subtraction of matrices. So, well, this is also another it's not difficult, just a simple way to do the requirement. So the requirement is that the matrix to be of equal dimension. For you to be able to subtract, then the matrix must be of equal dimensions. Each element of one matrix is then added to what? Or subtracted from the corresponding element of the other matrices. So before you do subtraction and add addition, the matrix should be of equal dimensions. So let's look at example here. I have for matrix A, what is supposed to get example where? No. I have, okay, so I have matrix A. For example, I have, if we have this format, I have this one and multiplying by this. You can see that the first part here is 2 by 2, 2 columns, 2 rows. So it's 2 by 2. If you come to this place, there are also 2 rows, 2 columns. So it is easily for you to what? Take the addition. For you to do what? Do the addition. Because if they are not the same, then you cannot do addition and subtraction with them. They must be the same dimensions. So we can see that this and this are the same. This and this are the same. So you can easily add and subtract them. So if they are the same, you see that this one, if you are doing addition, 1 is going to add to what? 7. So we have 1 plus 7. And then 4 is going to add to 2. So we have 4 plus minus 2. And because this is minus, so you just do this because the 2 is already minus. Then you come to the second one, 2 is going to be added to what? 6. So we have 2 minus 6 because the 6 is already negative. And then 5 is going to be added to 4. So we have 5 plus 4. Then you come to the last one, 3 is going to be added to 3. That is 3 plus 3. And then 6 is going to be added to 0. That is 6 plus 0. And at the end, you are getting the final answer to be 1 plus 7 is going to give you 8. 4 minus 2 is going to give you 2. Minus 2, 2 minus 6 is going to give you minus 4. And then 5 plus 4 is going to give you 9. 3 plus 3 is going to give you 6. And then 6 plus 0 is going to give you 6. So before you do addition, make sure that they have the same dimensions. Let's look at the second one. You can see that the second one, we have 2 by 2 here. But here is, this is 1 by 2 by 1. This 2 by 1. So it will not work. They are not the same. They are not the same dimension. So it won't work. It won't work. So we have 2 by 2 and we work 2 by 1. It cannot work. It cannot work. So before you must the additions to work, they have the same dimension. The same thing you are going to do with subtractions. So this one, they are the same. You can subtract them. You can subtract them easily. You can subtract 1 minus 7, 4 minus 2, and then 2 minus 6, 5 minus 4. Then you come to this place, 3 minus 3, and then 6 minus 0.
Hello.
Yeah, Manu.
Yeah.
La fuve fuma wela.
Yeah.
La fuve.
Wala.
En wela.
Wala.
Oh. Okay, sorry. Someone interrupted with the call, so we can proceed now. So I was looking at how to do the subtraction. Yes, so it's the same thing. So addition and subtraction is not something difficult. What you need to do is that make sure that they have the same dimension before you can start doing the substitution or the subtraction and then addition. Okay, so if you have this, for example, if you have this one, A is equal to this, B is equal to this, compare them, see whether they have the same dimension. If you have the same dimension, then you can do the exercise very nice. Doing the exercise very nice means that you are going to, the first one is to find A plus B. So add this one to this. You are just adding this to this, add this one to this, and add this one to this. Then you come and add this one to this one to this, and then this one to this. Then the last one, you come and add this one to this one to this, and then this one to this. So it's not something that's something simple. You can just do that yourself. Okay. Then you are going to do the subtraction. You are going to do the same thing for the subtraction. You are going to subtract this one from this one from this, and this one from this. While they are the same dimension, the subtraction and addition is not difficult. Okay. Now, what about this? You can also find to see if they are the same. You can also find to see if they are the same. Can you find, okay, this is saying that to find C plus D is not possible because they are not of the same dimensions. They are not of the same dimension. To also subtract C and D, they are not, it is not also possible because they are not the same dimension. So please take note of the dimensions or the requirement for addition and subtraction of matrices. Now let's look at some properties of matrix addition. We have the commutative property, we have the associative property, and we have the identity property. We have the identity property. So associative property, addition. So if you have matrix A plus B, it must be equal to the reciprocal, that is B plus A. So if you add matrix A to B, it must give you the same thing, adding B to A. That is what the commutative means. And then the associative means that if you add B, if you add matrix A, it means that you should have matrix A up to C, and you can verify whether this one will work or not. Guess the formula, follow the formula. First of all, you have to put the A there, then you add B to C. After that, you add it to A and see if you add A to B, and then later add it to C, whether you get the same results. And that is what we call the associative property. These are properties that you can always verify. Then we have the identity matrix, the identity property. So you have matrix A plus matrix B. It must be equal to A. So if you add matrix A and then to 0, the 0 means that it's a null matrix. It's a null matrix. So matrix A plus the null matrices is equal to A. It is same thing. It's like 1 plus 0 or 2 plus 0. It's the same number. So that's what the identity matrix is really talking about. So here, if you have matrix C, so here we have A, B, C, and D. If you want to confirm this one, the identity matrices, we are saying that you are going to add, let's say, matrix D to A plus D. It must be equal to A because these are all, the elements here are all 0. So you are going to be adding 1 to 0, 2 to 0, 1 to 0. You are going to get the same numbers, and you are going to add this one to 0, this one to 0, and this one to 0. You are also going to get the same numbers. So at the end, A plus D is the same as A because our D is 0. Our D is a 0 matrices. Okay. So these are all what, so given these matrices, given the matrices above these matrices, you can verify, which I will not do that with you. The verification, you can do that at your own convenient time. You are going to use the commutative rule that A plus B is equal to B plus A. So first, when you come to this place, this is A, this is B, add them, add A to B, then you get your final answer. You get your final answer. So let's add this plus this. We're going to give you 1. 1 plus 0 is going to give you 1. 2 plus 1 is going to give us 3. It's going to give us 3. And then 1 plus 2 is going to give us 3. It's going to give us 3. So write 3 here. Then you come to the second one, negative 2 plus 1. Negative 2 plus 1 is going to give us negative 1. And then 0 plus negative 3 is going to give us negative 3. And then 1 plus 1 is going to give us 2. So this is what you have for A plus B. A plus B. You want to know whether B plus A will also be the same. So you can do the same thing, B plus A. So we are adding B to A. So B plus A, you are going to get 1. Let me write it here. You are going to get 1. You have 1 plus 2, you are going to get 3. And you have 2 plus 1, you are going to get 3. Then you come to the B to B plus A, you are going to get 1 plus negative 2, you are going to get negative 1. And then 3 plus 0, you are going to get negative 3. And then 1 plus 1, you are going to get 2. Okay, so compare the two, A plus B. The A plus B is this one, and then B plus A is also this one. So you can see that they are all the same. And that verify this formula. That verify this formula. You can do the same thing to the rest of them. So first, this one first, add B plus C first. After getting the results, and you add that result to A, then you come to the other one, add A plus B first, then you add the result to the C and see whether they are going to be the same. Okay. So these are, I think we've even done it here. So you can see that A plus B is equal to, they are all the same if you add them. Okay. Okay, so we are still under examples of matrices, addition and subtraction. So this one subtracting this is the same thing. Okay, let's move on. And these are all examples, further examples that you can look at it. Further example that you can look at it yourself. We have A, we have B, we have C, and we are saying you should find 2A. 2 is a scalar. 2A. If you say you should find 2A, it means that you are going to multiply 2 by the matrices A. 6, 0, and 2 minus 1. This is what you are going to. So 2 is going to be a scalar. So you are just multiplying the 2 inside there. And that will going to give you 12. The 2 is multiplying every element, 4, 0, and then minus 2. 2 is just a scalar. And here you have 3b. 3b means that you multiply 3 as a scalar by B, the function, the matrix B. You do the same thing. Here we have 2A plus B. Where is 2A? The 2A is this one. You are going to multiply 2 by the A, then add it to B. Then you can also find A transpose. Remember that I said the symbol for this is the transpose, or sometimes you see A raised to the power T. It's the same as the transpose. So what we are going to do here is that for the fourth one, what we are going to do is that you are going to take the transpose of A and B, then you add them together. Transpose means changing column to rows and row to column. So here you have to write this one vertical. So you have 6 and 2. And also write this one vertical. You have 0 and minus 1. So this one becomes transpose of A. So you have A prime. What is B prime? B prime is also the transpose of B. Transpose of B. So what are you going to get here? This is B. What you do is that you change the rows to columns. So here you have 1, 2, and then 3, 4. You have done the transpose of this. Transpose of this. After that, you add this one to 1, this one to 0, 2 to 2, and then 1 to 4. And that will satisfy your fourth one. Okay, so these are something that you can do it and do it yourself very well. Okay. Please, if I'm going and you have questions, you can ask. And if you do that, this is what we call the scalar matrices. The scalar matrices. We have done the scalar matrices. We can see that the previous one, we say if you have A 2 raised to 2 multiplied by A, and A is a matrices, then the 3 is what we call a scalar. So the process that we have done so far is what we call a scalar matrix. A scalar matrix. And we have a lot of examples of the scalar matrices. We have example if A is equal to this matrix, B is equal to this, and 0 is equal to this. You can find 5A. The 5A means that you are going to multiply 5 by the matrix of A. That is 1, 2, and then 4 minus 2. Multiply them. Just multiply and get your product. That's all. Here will come give you 5, 10. Here will give you 20. And here will give you minus 10. That is all what we are talking about, the scalars. The scalar. Okay. And then if you also look at minus 3 over 2B. So here the B is giving us 3, 7, and then minus 4 and 1. So we are going to, this is 3. So we are going to multiply the whole of this one by this one by this one by this one by this, and this one by this. So first, if you multiply minus 3 by 3, so we are going to get 9 over 2. Here is going to give you 9 minus 9 over 2. Then you multiply this one by this. You are going to get this minus minus, it becomes positive. You are going to get 12 over 2. So you are done with this. Then you can multiply minus this one by this. You are going to get 21 minus 21 over 2. And you multiply this one by this. You are going to get minus 3 over 2. And this is what you are going to get. If you can simplify it, fine. If you cannot simplify it, you leave it like that. So it's a scalar. multiply the scalar by the main matrices, and you get your answer going. Okay. Yes, these are what we have done so far. So the same thing. And these are the properties as well, properties of a scalar matrices. So let me quickly run through this. If you have a matrix K is a scalar, and then A plus B, they are all different matrices. A is a matrix, B is a matrix. So if you add A to B, then you multiply by a scalar, it should be equal to it should be equal to A. So this one is K here. It should give you the same thing if you multiply this the K inside. If you multiply the K inside, you are going to get KA plus KB. That is what we mean. They are the same thing. So this one and this one are all the same. This one and this one are all the same. This one and this one are all the same. So these are all properties of the scalar matrix. Properties of the scalar matrices. Now move to matrix multiplication. So we learn to do addition and subtraction. We learn to do addition and subtraction. So let's move to the multiplication of matrices. So two matrices can be multiplied if and only if the number of columns in one matrix is equal to the number of rows in the other matrix. This is a rule that we have to follow. If the number of columns in one matrix is equal to the number of rows in the other matrix, then we can multiply them. In particular, we are saying that the matrix product AB is defined if and only if the number of columns in A is the same as the number of rows in B. In this case, the matrix A and B are said to be compatible or comfortable for multiplication. So that is the rule for us to be able to multiply two square matrices, then the number of rows or the number of rows in one matrices must be equal to the number of columns in the other matrices before we can do the multiplication. So let's move straight to demonstrate that with example. So here I have matrix A. Matrix A is we have one. This is matrix A. The number of rows we have. The number of rows here is one row, and the number of column here is also one column. So we can multiply them. So one column, one row. So we can multiply them. So how do we do the multiplication? This is another thing. Once the rows are equal to the columns, then we can multiply each one by each one. So we multiply 2 by 1 by 2, 1 by 2, then plus 2 by 3, plus another one, 2 by 3, plus 3 by 0. This is what we have here. Plus 5 by 1. This is what we have here. Okay, so you add all of them together, you can see that we are having only one. And because we have one row and one column, that is why we are getting a scalar. But the dynamics will change if we move on to further matrices. Okay. So here, if we are going to multiply this, here we have one row, one column. Can we multiply it? If we are going to multiply this one, it means that one row it means that we are going to multiply this one by this one by this one by this one by this. We are going to do that all for the first one. Then we come and use this one to this one by this one by this one by this, and this one by this to get the second one. Then we use this one by this. Obviously, you are going to get 002 out. Then this one by this one by this one by this, and you are also going to get this. So we can see that if you, the number of, we have 4 rows, 1 column. And why it is multiplicative, why it is compatible, because we can match 1 row to 1 column. So we have 1 row, 1 column, which is the requirement for the multiplication to what exists. We can multiply 1 row and 1 column. But meanwhile, we have 4 rows and 1 column. 4 rows. Under the 4 rows, we can see 1 column and 1 row there. That is why we are able to multiply this 2 out. So 2 multiplied by 1, it gets to be 2. 2 multiplied by 2 is going to be 4. So that is how the rules is going to work as well. Okay. Then if you have, let's say that the matrix example that we have observed, we observed that the product of A and B gave a 1 by 1 matrices. Let's look for further example. So let A will be a matrix, and then B is also a matrix. So we are going to determine whether the product A, B, and BA are defined. Can we actually find a solution to them? Can we actually find a solution to them? Okay. So if you are going to define A and B, so actually A and B, we said before you can multiply, the number of rows should be equal to number of columns. So let's see the number of rows here in one line here. So here, how many rows do we have? 1, 2, 3. How many columns? 1, 2, 3. So it means that the number of rows here is equal to the number of columns. The number of columns. So we can do the multiplication with this. We can do the matrix multiplication with this. So what we are going to do is that first multiply this one by this. So we have 4 multiplied by 2. 4 multiplied by 2. Then
-2.
Yeah, sorry, -2. I'm coming. 4 by -2 by -2, then plus 4 by 4 by 0. Yes, 4 by 0. That is 4 by 0. And then 4 by 3. So plus 4 by 3. 4 by 3. That's going to give you 12. 4 by 3. So here, the first one, you are going to get this is -8. This is -8. I'm coming. Just a minute. We are adding. So this 4 by -2, you are going to get -8 plus 4 by 0. I'm going to give you plus 12 plus 12. Okay. Plus 12. What are we going to get in all?
4.
Going to be positive 4.
Positive 4. Oh, sorry. Yes, positive 4. No. Sorry. Oh, I'm multiplying and you are also keeping quiet. You are not saying anything because
It should
we are
be
going.
row by
Yes, so it should be this one by this. Rows by
yeah.
columns. Yes, rows by columns. So you take 4 and multiply by this. Take 0 and multiply by this, and take 1 and multiply by this, and you add them up. Okay. So let's do for the first one and see. 4 by this is the same thing. That is going to give us minus 8. Then you plus 0. That is going to give us what? 0. And then minus 1 multiplied by 7. That is going to give you minus what? 7.
Minus 7.
Minus 7. And that is going to give us, add all of them,
Negative
negative 15.
15.
So that is the negative 15 that we have. The first one, negative 15. Then again, you take the same 10. You take the same 10, and multiply by the second one. Multiply by the second one. So here you are going to get 4 multiplied by 0. That is going to give you 0 plus 0 multiplied by 2. That is going to give us 0. And then 1 multiplied by 0 is going to give us what? 0. All of them is going to give us 0. So the second one we have 0. Then we move on to the third one. It's the same thing. You are going to multiply this one by the last one. This one. So you are going to have 4 by 3. That is going to give you 12. And then 4 by 1. That is going to give us what?
It's 4.
4 by 1.
So will it will be 0 multiplied by 1?
0 by 1. That is going to give us what? 0.
0.
And then 1 by 0 is going to give us 0. So at the end, we have 12. So that's the 12 that we have. So that will give you the first line.
You have 12 positive.
Yes. So the last thing is that, again, you will take this line here and start with this again. First, multiply by this. So let's do it and see. We are going to multiply 3 by 2. That is going to give a negative 6.
6.
And then multiply 4 by 4. That is going to give us plus 16.
16.
And multiply 2 by 7. That is going to give us 14.
14.
14. So add all of them together. What are we going to get? I think it's going to be 24,
You are going
right?
to get 26.
24 or 26?
Sorry, 24 positive.
Yes, 24.
It's 24.
Yes, so you are going to get 24. That is the first one. Then we do for the next one. This one is gone. So we are multiplying the same thing by this. So the first one, 3 by 0, we are going to get 0. And then 4 by 2, we are going to get 8. And then 2 by 0, we are going to get what? 0. So at the end, we are having only 8.
Positive.
Then the last one, we are going to multiply this one by the last one here. We are going to have 3 by 3. That's going to give us 9.
9.
Plus 4 by 1. That is going to give us 4. And then 2 by 0. That is going to give us 0. So at the end, we are getting 13. 13. Okay. So this is how the multiplication is being done. Rows, the number of rows must be equal to the number of columns before you can differentiate. Let's look at the second one, whether if that is, we are multiplying A by B. That's why we are able to multiply. We get it. Let's multiply B by A and see whether they are compatible to do that. If you multiply B first before A, it is telling you that we have here the number of rows is 3, but the number of columns here is 2. Sorry. The number of rows here is 3, but the number of columns here is only what? 2. So we cannot apply the multiplication rule here. For it to work, we must have them to be the same, like this one. Here is 3, here is 3. So we're able to do the differential or the multiplication. But here is 3 by 2, so we cannot do it. We cannot multiply it. So that is the intuition behind the multiplication. There are so many things we can do with the multiplication. These are, I guess, things that maybe we can do it. This is a transpose. This example, I don't know whether they brought it here again because BT means the transpose of B, and then AT means the transpose of A, and then A plus B means that you have to add A plus B first before you take the transpose. Add this one and this one first before you take the transpose. And then AT, BT means that after taking the transpose of A and B, then you add them together. What about AB? ABT. The ABT is also telling you that you have to multiply A and B first before you take the transpose. Multiplying AB first. This is column. This is row. The row is here, and this is column. They are two, so you can multiply them. So first, let's take this one and multiply this. So we are going to get 2 by 2, 2 by 3. 2 multiplied by 3 is going to give us 6 plus 3 multiplied by 2 is going to give us 6. 6. And that is going to give us what? 12. 12 here. Then you take the same 10 and multiply the second one. 2 by 1 is going to give us 2 plus 3 by 5 is going to give us 15. So here is going to give us 17. Then you go to the second one. Now we are now taking this and multiplying this first. So we are going to get 4 by 3. That is going to be 12. 12, and then the second one is 5 by 2 is going to give us 10. So the first one you have 22. One, the same thing, but you go to the other one. You are going to get 4 by 1. That is going to give you 4. Plus 5 by 5. That is going to give you 25. And that is going to give you 29. So here is going to give you 29 for the multiplication. Now, after you have finished multiplying, the next thing is that The next thing is that you will take the transpose. I'm talking about this part here. You take the transpose of the multiplication. So you now take the transpose of this. What do you mean by transpose? The rows become columns, column become rows. So you can rewrite this one. This one become vertical. So you have 12 and 17. And this one also become vertical. That is 22, 22 and 29. Okay. So this is what they are asking of here. But what about this one? This one means that you have to take the transpose of B first, transpose of A first before you multiply them. That is what it means. So these are some. Oh, I even did it. They said this question for your doing pressure, like it's an assignment. I don't know why I didn't look at it and I'm wasting my time. You should have go and try it yourself. Okay. Okay. So let's look at this. If you have matrix A is 3 by 5, and B is 5 by 3, and you are going to multiply A by B, what will be the resultant matrices? What will be your final answer? What will be the dimension of the final answer? The dimension of the final answer will be 5 by 5, because the first one you are starting with 3. So take note, this is very important. You have to know the dimensions and the results first before you conclude. If you have matrix A to be equal to this, matrix B is equal to this, and you are going to multiply A by B, this one is going to obviously go with this. Because we are dealing with the A first, you will go with this, and the resultant matrix is going to be 5 by 5. The final thing you're going to be 5 by 5. But if you are having C, matrix C to be equal to 3 by 5, and matrix D is equal to 7 by 3, and you are going to multiply C by D, it means that this obviously is going to cancel out, and you are going to have 7 by 5. 7 by 5. But if you are going to multiply B by A, you are going to get 3 by 3. Because B by A, the 5 here will cancel 5 here, and you have 3 by 3 to do with it. Okay. So these are all matrices that we have the associative rule, and this we have looked at them so far. And these are all examples that you can look at this. So we are given matrix A, B, C, D, and I, and they're asking you to prove that A, B, C is equal to A, B, D, C. We have looked at them. So it is just an assignment that you have to go through yourself. Okay. Let's see how many minutes. Okay, so let's see if we can finish the determinant, then we can close from there. So let's look at what determinant is. The determinant of a matrix is a scalar number, and it is obtained from the elements of matrices by specifying the operations which is characterized or the characteristics of the matrix. So when we talk about the determinant, we are talking about it's the same as a scalar matrices. But these scalar matrices, we have a way of determining the scalar matrices, and the determinants of the scalar matrix only defined for a square matrices. For us to find the determinant, then the matrix must be a scalar matrices. So methods for obtaining determinants are discussed below. Let's see the methods for finding the determinants of a matrix. When we have 2 by 2 matrices, it is called a second order determinant, and it is derived by taking the product of the elements on the principal diagonal and subtracting from it from the product of the other that principal or the off diagonal. So we have 2 by 2 matrices. The determinant is very simple. If we have 2 by 2 matrices, we can find the determinant if we multiply the principal diagonal, if we multiply this one by this and subtract it from this one by this. Okay, so this one, the product of this minus the product of this is what we call the determinant. So let's look at example quickly from 2 by 2 matrices. We have a matrix A. Matrix A is equal to 3, 4, minus 6, and 1. And you are asked to find the determinant. The determinant is dominated by an absolute value, this. So anytime you see this or any number B, and you see this line there, and you see this absolute line there, maybe we are talking about the determinant. So determinant is dominated by this. How do we find determinant? We multiply the product. We multiply the product and subtract from the off diagonal. So if you look at this, the determinant is equal to, we are multiplying 3 by 1. 3 by 1 is going to give you 3. And you subtract it from the product of the off diagonal. So we multiply 4 by 6. 4 by 6 is going to give you minus 24. Minus 24. So you have 3 plus 24, and that is going to give you 27. And this is the determinant that we are talking about. So finding the determinant using 2 by 2 matrices is not something difficult. The second one is finding the determinants of B. If B is equal to minus 1, 0, 6, and 10, we can easily find the determinant. How do we do that? You multiply 1 by 10. That will give you minus 10. And you subtract it from multiplying 6 by 0. That will give you 0. And the determinant is going to give you minus 10. Okay, so this one minus this is what we call the determinant. So you can find this one as well. What you need to do is that just multiply this one. It will give you 20, and you multiply this one, and then this one multiplied by this, I think it's going to give you 3.5 minus 3.5. And you subtract them and get your determinant. What about the determinants of 3 by 3? The determinant of 3 by 3 is also being defined in 2 different ways. It's also we can find the determinant by 3 by 3 of 3 by 3 by using the Laplace, the Laplace method, and then the Saros method, and then the Saros method. So let me just go quickly to it. So we have the 2 method, Laplace method, and then the Saros method. Saros method. Let's look at the steps for us to find the 2 methods. First, let's do with the Saros method, and let's look at the steps. Add the first 2 columns. Add the first 2 columns at the end as 4th and 5th column. Then second, compute the product of the 3 diagonal from the left to the right, from the left top to the right bottom, and add them. And from this value, we subtract the sum of the product of the 3 diagonal from the left bottom to the right bottom. This is English. Let's go on to work and see what they are talking about. Now, I just want to use the example to explain what they mean by that. If you want to find the determinant of 3 by 3 matrix, there are 2 methods. The first method is what we call the Saros method. And what the Saros method is saying that add the first two columns. These are the first two columns to the last. So I have 2, 1, minus 1. And I also have 3, 2, 0, minus 4. And I also have 5, 5, 2, 2. This is my first matrix. This is the matrix that I have. This is the matrix that I have. Now, the Saddles method is saying that add the first two matrices to the main one at the end as fourth and fifth. So we are going to add this one to the matrix. So we are adding this one to the main matrix. So we have 2 here. We have 1 and minus 1. Then the last one is you add another one, 3, 0, and minus 4. This is what the Saddles is saying. The Saddles is saying. So if you do this, this is what you have. Now, the next one is that the principal diagonal. The principal diagonal. So here we have this from here. This is our first principal diagonal. This is our second principal diagonal from here. And then this is our fourth principal diagonal from here. Okay. So what it's saying is that multiply all this one and add them up. So we are going to multiply, that is what we have here. Multiply 2 by 0 by 2. So you are going to, the first one, you are going to have 2 by 0 by 2. That's the first one. Plus, you multiply 3 by 2 by minus 1. So you are going to get 3 multiplied by 2 multiplied by minus 1. Then you add it again. Then the last one, you are going to multiply 5 by 1 by minus 4. So 5 by 1 by minus 4. And you add them together. And you add them together. So here we're going to give you 0. Here is going to give you minus 6 plus minus 6. Plus minus 6. And here is going to give us minus 20.
Is it minus?
Minus 20. So at the end, we are going to get minus 26. We are going to get minus 26. Now, this is the first principal diagonal. This is the principal diagonal. Now, you have minus 26. So that is what we have. So let's clean this and clean these ones. Okay. So the principal diagonal, if you multiply and sum that up, you have minus 26. Did they work it? Let me see. Yes. Is it minus 26 or minus 16? Okay, let's see. Now, the second one is that you are going to take the off diagonal. So you are going to this one and this. Minus 1, 0 and minus 1, 0. This is 3. So we are going to have this one as off diagonal, the first one. So this one will come here. Then another one will come here. And then the last one is this. Yes. So again, we are going to multiply this one and add them up. So we are going to, the first one, we are going to get 0 because 1 multiplied by 0 is 0, 0 multiplied by 5. So it's going to give you 0 here. Then the second one, 4 by 2 is going to give you, that is 8, minus 8, and this is minus 16. Minus 16. Minus 16. And the last one is 2 by 2 by 2 by 2. That is going to give us this. Yes. That's team.
Sir, can I hear you?
We can hardly hear you.
The network, please. Tell him maybe network.
He's no more showing the screen.
By talking.
He's talking. And I can't hear anything. No.
Same here.
Now they ask you the screen.
With the network issue.
Madam Florence. Madam Florence. Mr. Isaac.
Yes, hello, madam.
Yeah, good morning.
Morning, madam. How is it?
Oh, we are fine. What about you?
Quite well.
Mm,
I just lost contact with the lecturer, or I am the only person.
You are not the only person. So I was trying to alert Madam Florence to at least give him a call to verify what's the problems about.
Hello, class.
Hello.
Hello, Miss Irie. Please, it's
Yes,
like we
sir.
lost contact with the lecturer. If one can link him up and then alert him. If not, he will be speaking alone.
I think he's no more on the platform. He's off. He's off. Not even there. He's not there at all. Let's see. Because of the network, maybe he will come back. Let's wait.
As is it I'm the only one who was not following the integration calculus issue? If you also have the same challenge, let me know. Or software, I don't know what we're doing.
Integration and what?
The calculus, the defense unit. What were we doing?
Elias, so please, what did you say?
Mr. Ilyasu, I just even joined, so I think you should be my TA.
Hear from you about calculus issue. Is it not teaching the matrices, or the calculus was done before the matrices?
Oh, that was a unit 1. You know, this is a unit 2.
So you are talking about the previous lessons or today?
Now I'm talking about the
Today's
previous,
lesson, we touched on.
we touch on that one.
May I join it not quite long, so I know he's only treating the matrices, or?
Oh no, you completed that one before you came to this one.
Yeah, you completed before moving on to the matrix.
So was he doing what? Integration or differentiation?
It was further integration. So after that, he moved to the matrices.
So meaning that he's going to give us a slice today.
Have you already had the unit 1? Have you already had the
Isaac,
It's a matrix that we don't have, which I believe maybe after this you'll give it to us.
Into it, yeah.
So are you also facing the same challenge, or I'm the only one? So
No facing it. The network.
You guys following, it's like you guys understand the issue.
We guys are what?
You understand the calculus and further integration very well. I think I was the only one who was lost. You guys, the way you guys quiet and following, I was shocked. I don't know. You questions on that. You don't know where to even start from. What other kind of questioning? What kind of advice are you doing? What is that?
Be silent, be soft.
We are handling matters. We are handling matters.
Sir, beware.
Hey,
What
that's
is
what I
it?
say was
What is it? Just like this calculus thing is not easy.
you have to tell the man that the better you can put not that
They are following the
I think this one is okay.
Yes,
not the matrix, not the the issue is the unit one. Not for the matrix, that one is a bit okay. We can be able to follow to a certain extent. But the challenge is with the unit one.
Yeah, the unit one.
The
Lagrangian and the
for more than 30 minutes. So imagine they bring such a question in exam. How are you going to even finish within time?
Oh, there's no way you can finish.
The Lagrangian.
So
look at the way you
what?
talk in
You cannot finish, but you can start.
You don't even know where to start from.
You cannot finish. Hey.
You start. You don't reach an answer because you are dealing with time.
I mean, you guys will have some of us before it's too late. Or you want us to run away?
Come again.
I should have time before we run away.
Run away of what? Run away of what?
Mr. Douglas.
Doug said you shouldn't run away.
That's it. The more you ask questions, the more you confuse the process. So sometimes you are fine them just be following it. I think say has joined.
Network.
Hello, can you hear me?
Yes, sir.
Yes, sir.
Oh, okay. We are almost running out of time, and I don't want to start anything again. Where did I stop?
Determinant of
Ferrous metals we are using to.
Okay.
Criminals.
Yes. So maybe let's stop here then. After your quiz, we can meet again to finish it up. Is that okay?
Yes, sir. The slide.
Doctor, who the slides or the slides?
Yeah. I will send the slides to you. This slide you don't have it, so I will send it to you. Yeah.
Okay. Thank you.
All right. So after your quizzes, we can meet and then wrap it up.
So we hope you are going to get the slides today.
Yes, sure. Yes. After here, I'm like.
But any time for question.
Yes.
So,
for
the message is okay. We are picking them. So, more questions should come from there. Because for the first one, there is we have difficult more.
Come again.
I said the message we are picking it up by the first one. That calculus, we have some problem. So, your questions should come from here. Message more. We understand it. But
oh, I'm not getting you. It's like your line is breaking or something.
So you saying that
yes, someone should tell me what he said.
What
He's saying that the mattresses
that the mattresses question should be brought we should bring that one to the quizzes and exams since we have more knowledge or have understood it more as compared to the calculus one. So please do something about it.
Ah, okay. I will suggest to my
All
boss.
inclusive, all inclusive.
Yeah. I think that would be fine. It's not a bad suggestion, though. Especially the especially the exams, we should bring more of that. Eh?
Yes.
And
Yes,
then
sir.
we
Yes, sir.
Okay, I see.
We pray that it will work.
It's only 21 minutes, so we please. Thank you.
If Laganja comes here, we can't work within 21 minutes.
What the Mama Koya all inclusive, Mama Koya one way. Na a tepaswa.
So okay. Who can what you say, Kakra? But calculus no dey. I know she.
Dog, we all do like render with the one.
The Lagrange.
The Laganja dog can teach about 5 minutes to solve it.
That's agenda topic.
Come again.
It can take you about 5 minutes to solve
It's
it.
an agenda topic.
All right. So let's finish the what we are supposed to do first. Maybe, like I said, if I get time this time, we'll do the tutorials again, and then we'll solve more questions on that.
Okay, dog. We appreciate.
Thank you,
All right.
God.
So you have a wonderful
Thank you,
day.
Doc. God bless you.
Thank you very much, sir.
And God bless you.
My brothers and sisters, have you gotten the timetable?
Check your portal. Is there? Go into your portal. You find it.
Eating time, no talking.
I've not been seeing it too. That's why I'm asking.
So you want to get into
Go to your
portal.
portal.
Is there?
Find it there. In your portal.
Please. Those who have it, just put it on the platform.
Or you don't have a portal.
We have them. Time to go and then it will.
Go to your portal. I want to check. You find it.
Madam,
Class web can also share it on the platform.
exciting.
Hello, but see, I didn't hear from you yesterday.
Helen.
Hello.
I'm sure you're okay.
Please, yesterday you met the
Helen, are you okay?
surveyor man.
Yes.
Okay.
Oh, I didn't join you. I later saw that you have a class. Yeah.
Oh, why should we
When was the time I started? I couldn't get the time. That's why. Oh.
I joined late.
Oh.
House. House.
Please, please, Madam Flores. Hello? What's an approach? Sorry. What's affecting?
Mm.